Let's talk about finding vertical asymptotes of rational functions. To understand this process, it's a very simple process, but to understand why it works the way it does, we need to go back to the definition of a vertical asymptote. Now, I'm not going to be very precise here with the definition, but recall that a vertical asymptote is where we kind of blow up to infinity somewhere. So for example, if we have a vertical asymptote right here, we just kind of shoot up there, or maybe we shoot down. We do one of these at least. And so this is what a vertical asymptote is. Now, the way that this happens, the way a y value blows up to infinity or negative infinity, in rational functions, this happens only in one way, and that is when you try to divide by 0. In other words, you're dividing by numbers that they get really, really, really close to 0. So the most basic example of this is just 1 over x. Okay, as x gets really close to 0 here, well, 1 divided by a really tiny, tiny number is a huge number, right? And the closer x gets to 0, the bigger that this 1 over x is in magnitude. So that's how we end up with vertical asymptotes. But you have to be careful. Some people will kind of just say, oh, well, anytime you divide by 0, you're going to get a vertical asymptote. And that's not actually true. And a very, very simple counterexample to this is if I had x over x. Okay, x over x obviously is not defined when x is 0 because we'd be dividing by 0. It's not defined. But as x gets really close to 0, even though our denominator is getting really close to 0, so is our numerator. Right? X over x is equal to 1 if x is not equal to 0. And so no matter what x is, as it gets close to 0, x over x is 1. And so x over x is not a very interesting function, but it is a rational function, and it doesn't have a vertical asymptote when x is 0 because its reduced form is just 1. And its reduced form is not trying to divide by 0 when x is 0. So that's the important thing here. And so this takes us to our 2 steps that we're going to follow when we're finding vertical asymptotes of rational functions. The first thing we're going to do is reduce the fraction. We want to get rid of any cases like this where even though we'd be dividing by a 0 somewhere, it turns out the numerator also has that, and so it doesn't actually blow up. So we want to reduce the fraction, and after we've reduced the fraction, every 0 of the denominator will be a vertical asymptote. Let me give you a very quick example. We have r of x, our rational function, is we'll say x squared plus 4x, and then over an x squared minus 3x. Okay, and so to reduce this fraction, we're going to factor the numerator. We can factor an x out of that. We have x times x plus 4. And in the denominator, we factor an x out. We have x times x minus 3. Now, this here, we see there's a common factor here of x on the top and the bottom. And so now what we're going to do is just cancel that out. We cancel that out. Now you have to be very careful because if we cancel it out, that's assuming that x is not 0. And so when we say that now this is equal to x plus 4 over x minus 3, it's actually only that if x is not equal to 0. Okay. So this is our reduced form. I like to call that little r of x. Okay, I use a lowercase for my reduced form. So I've got my x plus 4 over x minus 3. And now that I've reduced my fraction as much as I can, I now look at the zeros of the denominator. So I just look at this denominator, x minus 3, and I find its zeros, meaning I set it equal to 0, and I solve for x, and I get x equals 3. And that is the 0 of the denominator. It's the only one. So this is a vertical asymptote of that original function. So it's a very basic, simple process, but it's important to understand why, and that's that just because you're dividing by 0 doesn't mean that something blows up, because your numerator might be getting close to 0 as well.